Bismillahirrahmanirrahim. Welcome to my YouTube channel. This is Hamza Noor from Aero Education Network. And in this particular video, I'm going to discuss a few past paper questions from International A-Level Edexcel P3, Pure Mathematics 3. Chapter number 1, Algebraic Methods is completed in my online batch of P3 January 2027 session. Okay, those students who are appearing in June for P3 exam, they are also studying they are also completing their syllabus in the very same January 2027 batch. Okay, so my purpose is to, make maximum lectures in English. This time I'm recording each and every lecture in English. I'm trying my best as much as I can. Okay, and this recording inshallah is going to be uploaded as a public video on my YouTube channel. Even for my enrolled students, I am recording maximum lectures in English this time. Okay, so basically these are the walkthrough lectures. Okay, the solutions are already done, already discussed with my students in my online classes. Okay, and here I am separately making walkthrough lectures in English. Okay, so inshallah, we are going to discuss each and everything in detail. So let's start with this past paper handout. So first of all, we have, this past paper question, June 2006, C3, question number 1, the old specification of P3. Okay, those past paper questions are still important for you. All right. So these are some old questions over here. We will also discuss the latest questions as well throughout the session and in my upcoming recordings as well. Okay, so in part A, we need to simplify 3x square minus x minus 2 divided by x square minus 1. All right, so in part A, we need to do the simplification. So first of all, I'm going to factorize 3x square minus x minus 2. Okay, so I'm doing the factorization steps. Alternatively, what you can do is you can use the calculator equation function mode and solve the polynomial with a degree of 2 and obtain the roots and then obtain the factorized form. And from this step, you can come directly on to this step. Okay, but in the meantime, when you switch your calculator mode and come back to the original mode, in the meantime, you can do the factorization as well if you are quick with it, effective with it. So I try my best to do the factorization steps as much as I can in each and every question. Okay. So the thing is that I did the factorization. So 3 times 2 is 6, and after subtraction, we need to get minus 1 in between. So in place of minus x, I'm going to write 2x minus 3x. So 3x squared plus 2x minus 3x minus 2. So taking x common multiplied by 3x plus 2, taking minus 1 is common multiplied by 3x plus 2. So 3x plus 2 multiplied by x minus 1 is the fully factorized form of the numerator. So now I can say that in place of 3x squared minus x minus 2, I can write the factorized form 3x plus 2 multiplied by x minus 1. And this is divided by x squared minus 1. So x squared minus 1 is basically a difference of squares, which means x squared minus 1 is squared. This will be factorized as x plus 1 multiplied by x minus 1. Okay, since you are studying since O level and IGCSE math, that when you factorize a square minus b square, what you get is a plus b multiplied by a minus b. So in place of x square minus 1, we are going to get x plus 1 into x minus 1. Therefore, x minus 1 got cancelled out, and you are left with 3x plus 2 divided by x plus 1. Okay, so this was the working of part A. After this, we have part B, hence or otherwise express 3x square minus x minus 2 divided by x square minus 1. And then we need to subtract this fraction, meaning here we have minus sign and 1 upon x into x plus 1. Okay, so we need to express this as a single fraction in its simplest form. So first thing first, what we know the matter of fact is that in place of 3x square minus x minus 2 divided by x square minus 1, we can exactly write 3x plus 2 divided by x plus 1. Okay, the outcome of part A, the answer of part A. So now my question is like this. Okay, in this form, 3x plus 2 upon x plus 1 minus 1 upon x into x plus 1. And now we are going to take the LCM. Okay, and a simple trick is that, the factor which is being exactly repeated will come once. Okay, I've discussed this thing in very much detail with my enrolled students, along with, some more detailed explanations about the LCM. Okay, so the factor which is being exactly repeated will come once, and the remaining thing will be multiplied. Okay, you don't need to, always show the steps in this way, that we are finding the LCM of x plus 1 and x into x plus 1. But anyways, if I do the steps over here, so starting from x, so x plus 1 will come as it is. Okay, because when x is multiplied by another expression, you won't get exactly x plus 1. So x plus 1 will come as it is. However, x will be multiplied by x plus 1. So this will give you x into x plus 1. And then you have x plus 1 into 1 and x plus 1 into 1. In the end, when you are left with 1 comma 1, so whatever the product of these terms is, that is basically the LCM. Okay, in the very basic questions, the book questions and examples we have done in this way. But now, in all of these questions, you don't need to show these steps. All right. So that's basically the whole thing. So the factor which is being exactly repeated will come once. Okay, जो factor repeat हो रहा है वो exactly एक मर्तबा आएगा. All right. So, and the remaining thing will be multiplied. So x plus 1 will come once and x will be multiplied. So x into x plus 1 will be the LCM. And now you need to ask yourself by what term you multiply x plus 1 such that you get this complete expression. Obviously, you multiply it with x. So the numerator 3x plus 2 will also be multiplied by x. So x into 3x plus 2. And then we have the subtraction sign, and x into x plus 1 will be multiplied by 1. Okay, so you will get the LCM over here, and the numerator 1 will also be multiplied by 1. So x into 3x plus 2 minus 1 completely divided by x into x plus 1. All right, so now we are going to expand the numerator. So 3x squared plus 2x minus 1 divided by x into x plus 1. And I did the factorization steps of the numerator. Okay, so, the factorized form turned out to be x plus 1 into 3x minus 1. Okay, I've shown the factorization steps over here, which are not a compulsion to do so. You can use your calculator equation function mode, obtain the roots of a polynomial with a degree of 2, and then you achieve the factorized form in this way. Okay, but remember that whatever integer can be taken common will be taken common first. Here, in this expression, there is no integer which can be taken common. So you write this expression as it is in the calculator equation function mode. All right, so that's basically the whole idea behind this. So here we did the factorization. So x plus 1 into 3x minus 1 divided by x into x plus 1. So x plus 1 got cancelled out, and therefore you are left with 3x minus 1 completely divided by x. Okay, so this was the answer of part B of this question. Okay, so now let's move on to the next page. So up next, we have handout question number 2, which is January 2007, C3 question number 2. Okay, fx is equals to 1 minus 3 upon x plus 2 plus 3 upon x plus 2 whole square, where x is not equal to minus 2. Because, if x was equals to minus 2, then the denominator would have become 0. And, the function fx would have become undefined. Okay, in part A, we need to show that fx is equals to x square plus x plus 1 divided by x plus 2 whole square. Okay, where x is not equal to minus 2. Okay, so in part A, we need to express this as a single fraction. So here we have the working for part A. So basically, 1 is basically a whole number over here, right? But if you want to write 1 as a fraction, so you can just simply say 1 divided by 1. जब 1 के नीचे कुछ भी नहीं है तो 1 के नीचे 1 तो आएगा ना. All right. So in place of this 1, you will write 1 upon 1. And then, the remaining two fractions like this. Now, the LCM would be x plus 2 whole square. Why? Because here I gave a basic illustration. Okay, if you want to find the LCM of x and x square, so what usually students say is that these two terms will be multiplied and x cube will be the LCM. However, this is not the case. Okay, when two terms are being multiplied to get the LCM, so those terms are completely different, distinct, distinguished, you can say. Okay, if you want to find the LCM of 3 and 2, it would be 3 multiplied by 2, which is 6. But when you need to find the LCM of 2 and 6, so you are not going to say that the LCM is simply just 2 multiplied by 6, which is 12. Okay, there you basically do the steps. Here I am just trying to explain you that if you want to find the LCM of x and x square, this basic concept you are studying since O level and IGCSE mathematics. All right. So if you want to find the LCM of x and x square, so starting from x, so x multiplied by 1 will be x, and x multiplied by x will be x square. And then below this 1 will come exactly as it is. Okay. And x multiplied by 1 will give you x. In the end, when you are left with 1 comma 1, so the product of these terms is basically the LCM. So the product is x square. Now, in the very same way, if you want to find the LCM of x plus 2 and x plus 2 whole squared, so x plus 2 into 1 will give you x plus 2. However, x plus 2 multiplied by x plus 2 will give you x plus 2 whole squared. Okay, and then 1 will come as it is underneath 1. Okay, since you have already obtained 1, and x plus 2 will be multiplied by 1 so that you will get x plus 2. In the end, when you are left with 1 comma 1, so the product of these terms is basically the LCM. एंड में जब 1 comma 1 बच जाता है तो इन टर्म्स को मल्टीप्लाई करा के LCM आ जाता है. Okay, so when we are multiplying these two expressions, so we are obtaining x plus 2 whole square. Anyways, these steps are not a compulsion to show. You just need to use the basic sense. But in some questions, I do the steps. In some questions, it's pretty much obvious. So sometimes I skip these steps. But here, just for the ease of the students, just for the sake that they don't forget these important things, I usually repeat these steps throughout my lectures, throughout my recordings, okay, and throughout the classes. So anyways, LCM we obtained was x plus 2 whole squared. And now you need to ask yourself by what term you multiply 1 such that you get x plus 2 whole square completely. 1 को ऐसी कौन सी टर्म से मल्टीप्लाई कराएं कि x plus 2 का होल स्क्वायर आ जाए. Obviously you need to multiply it with x plus 2 whole square, so this numerator 1 will also be multiplied by x plus 2 whole squared. And then we have the subtraction sign. Okay, and you need to ask yourself by what term you multiply x plus 2 such that you get x plus 2 whole square. Obviously you multiply it with x plus 2, so the numerator 3 will also be multiplied by x plus 2. And here the minus sign is already over here, which I've mentioned. Okay, so after minus sign, we have 3 into x plus 2, which means minus 3 is multiplied by x plus 2. All right. And then you need to ask yourself by what term you multiply x plus 2 whole square, meaning by what expression you multiply x plus 2 whole square such that you get this LCM over here, x plus 2 whole squared. Obviously, you multiply it with 1. So the numerator 3 will also be multiplied by 1. So now I'm going to expand the numerator. So x plus 2 whole squared, when this is expanded, this will give you x squared plus 4x plus 4, obviously, and then minus 3x minus 6, and then plus 3. So when you simplify the numerator, what you get is x squared plus x plus 1, and this is divided by x plus 2 whole squared. So therefore, we have obtained fx in the required form. Fx is equals to x squared plus x plus 1 divided by x plus 2 whole squared. All right, so after this, we have part B. We need to show that x squared plus x plus 1 is greater than 0 for all values of x. As you are already aware that such type of questions also used to come in P1. Okay, and such types of, steps of proof we also used to show in P2 as well. All right, in P2, when we did the questions of proof, okay, so in those type of questions we have attempted more technical expressions as compared to this. So this is just a piece of cake in front of whatever we have covered in P2 and P1. All right. So the concepts of AS are going to be tested in A2 as well. Okay. So that's basically the thing. Anyways, I'm going to, you know, explain it to you in detail and do the complete justice with this part B. Okay. First of all, here we have an approach in which we can, convert this expanded form x square plus x plus 1 into a completing square form. Okay. My usual way of, converting a general form of the quadratic expression into a completing square form is to basically use this formula. Okay. And other version of this formula is given to you in the P1 textbook as well. Okay. In which, in the book, in P1 book, the formula is mentioned in this way: a multiplied by x plus b over 2a whole squared plus c minus b square upon 4a. Okay, this 4a is underneath minus b square, not c. But if you express this as a single fraction, so 4ac minus b square completely divided by 4a. Anyways, my usual practice is to use this formula. Sometimes I use equating the coefficients as well. Okay, so anyways, I'm going to convert this ax square plus bx plus c into completing square form by using this formula. All right, so a is equals to 1, b is equals to 1, and c is equals to 1. Okay, and after completing the square, what I will do is I'll just explain it to you in this very same page. Okay, so just bear with me, hold on. First of all, I'm going to convert this general form of the quadratic expression into a completing square form. So a is 1, b is 1, c is 1. So a multiplied by x plus b over 2a whole squared plus 4ac minus b squared divided by 4a. So 1 multiplied by x plus half whole squared plus 4 into 1 into 1 minus 1 squared divided by 4. So x plus half whole squared plus 3 over 4. This is the completing square form. Okay, so as you are studying since P1 as well, and you have applied this thing in P2 as well, that anything is squared is always greater than or equal to 0. Anything is squared. दुनिया जहां की किसी चीज का स्क्वायर कर दिया जाए, it is always greater than or equal to 0. Anything is squared is greater than or equal to 0. Okay, here we have a brief illustration about this. Let's say if x is equal to 0, so the square of 0 is also 0. So x square will also be 0. If x is greater than 0, then x square is also greater than 0. Makes sense. But if x is less than 0, so x square is going to be greater than 0. So when you combine this equation and inequality, you can say that x square is greater than or equal to 0 for all values of x, which means anything is squared is greater than or equal to 0. Okay, you don't need to mention all of these steps over here. I'm just giving you a brief idea about this, a basic, explanation about this. Okay, so, since anything is squared is greater than or equal to 0, so obviously, x plus half whole square will also be greater than or equal to 0 for all values of x. Now, when you have something which is greater than or equal to 0, and you are adding a constant after that, you are adding 3 over 4. Okay, so the whole outcome is going to be greater than 0, strictly speaking. If anything is greater than or equal to 0, and we are adding a positive constant after that, okay, so the whole outcome of this is supposed to be greater than 0, strictly speaking. Okay, that's why we use a strict inequality over here. So this definitely implies the fact that x plus half whole square plus 3 over 4 is greater than 0 for all values of x. Okay, whatever values you choose for x, you know, the outcome of this expression will always be greater than 0, isn't it? So this definitely implies that, x square plus x plus 1 is greater than 0 for all values of x, because this completing square form and this general expanded form, they both are identical to each other, both are identities of each other. If you expand this x plus half whole square and then add 3 over 4 and then simplify, so the whole expression would be x square plus x plus 1. So therefore, x square plus x plus 1 is greater than 0 for all values of x. This is basically one way to do this, to convert this general expanded form into a completing square form. Alternatively, what you can do is, you can consider the discriminant of this quadratic expression x square plus x plus 1. Okay, you can see the nature of the roots. So the discriminant will turn out to be less than 0. The value of b square minus 4ac will be below 0, which would mean that there are no real roots. And since the coefficient of x square is positive, so the quadratic graph would be a least standing point quadratic graph, which will be completely above the x-axis. Okay, so these type of questions we also used to do in P1 and sometimes P2 as well. So here I have only discussed this approach and I've just briefly gave you an overview about the second approach. Okay, so here this solution of part B is done. So now let's move on to part C. Okay, so in part C, you need to show that fx is greater than 0 for all values of x where x is not equal to -2. Okay, because at x is equals to -2, we would have an asymptote if we make the sketch of the graph of fx. Because at x is equals to -2, this function fx is going to be undefined. Okay, so we have this condition for the fx function. Okay, so we need to consider this domain as well, that x is not equal to -2. Okay, so we are going to talk about any values of x other than -2. For all values of x where x is not equal to -2, this means that for all values of x other than -2. Okay, so here is basically the whole idea. Anyways, this fx function, fx is equals to x square plus x plus 1 divided by x plus 2 whole square. So in place of x square plus x plus 1, I can write x plus half whole squared plus 3 over 4. And this is divided by x plus 2 whole squared. So first of all, in part B, we have shown that x square plus x plus 1 is greater than 0 for all values of x. This means that the numerator of fx is positive. Agreed? The numerator of fx is positive. And since you know that anything squared is greater than or equal to 0, okay, so x plus 2 whole square will be greater than or equal to 0 for all the values of x. But we need to, consider this thing that x is not equal to -2. Okay, simply because, if you use x is equals to -2 for this expression, x plus 2 whole square, in which I substitute -2 in place of x, this thing will be equal to 0. But we don't need this value of x, which is -2. All right. So therefore, I'm going to write my statement in this way. X plus 2 whole square is greater than 0. Strictly speaking, greater than 0 for all values of x where x is not equal to -2. Okay. Because this is compulsory. Because this is compulsory to consider this domain that x is not equal to -2. Because खुदा न खास्ता अगर x -2 के बराबर हो गया तो फंक्शन अनडिफाइंड हो जाएगा. If x is equals to -2, so fx function would become undefined. Okay, only due to this reason we are considering this thing. So you need to write your statement according to the domain which is specified in the question. All right, according to the input values which are specified in the question. So x plus 2 whole square is greater than 0 for all values of x where x is not equal to -2. So, this obviously shows you a very basic conclusion that this denominator of fx is also positive. Denominator of fx also is also positive. Is also positive. You just remove this is. I just wrote this additional. Denominator of fx is also positive. Okay. So therefore, I can say that fx is greater than 0. Therefore, fx is greater than 0 for all values of x where x is not equal to -2. Okay. So in this way, we have attempted this part C. We have shown our complete proof over here. We have proved, that fx is greater than 0 for all values of x where x is not equal to -2. So here you go. Now let's come on to the next question. Okay, here we have handout question number 3, which is June 2007, C3, question number 2, part A only. Only part A we need to solve. Okay, because in the past paper questions, in a single question, multiple topics can be tested. Sometimes this topic can come with functions, sometimes differentiation. Okay, so sometimes with integration as well, even. So here we are only attempting those specific parts which are related with P3 chapter number 1 algebraic methods. So that's basically the thing. So fx is equals to 2x plus 3 upon x plus 2. And then we have subtraction sign, and then we have the second fraction, okay, where x is greater than half. Okay, show that fx is equals to 4x minus 6 divided by 2x minus 1. So basically, first of all, I factorized this denominator, 2x square plus 3x minus 2. Okay, so 2x square plus 3x minus 2. I'm going to factorize this. So 2 times 2 is 4. And after subtraction, we need to get 3 in between. So 2x square plus 4x minus x minus 2. So taking 2x as common multiplied by x plus 2, taking minus 1 as common multiplied by x plus 2. So completely factorized form is x plus 2 multiplied by 2x minus 1. Okay. Alternatively, you can use the calculator equation mode and obtain this factorized form. Okay. So, therefore, fx would be something like this. 2x plus 3 upon x plus 2 minus 9 plus 2x divided by x plus 2 multiplied by 2x minus 1. So as we can see that, x plus 2 and x plus 2 are exactly being repeated. So they will come once. जो फैक्टर रिपीट हो रहा होता है वो एग्जैक्टली एक मरतबा आता है. Okay, my main purpose is to record lectures mostly in English. Sometimes I use Urdu phrases, Urdu sentences, but I always make sure whatever I have said in Urdu, I will translate it into English as well. Okay, so that's basically the reason of the tempo, the momentum of the speaking. Sometimes I include the Urdu phrases, but don't worry, whatever I will say in Urdu, I will translate it into English as well. Because most of my online batch students, majority, almost all of them, they are well versed with Urdu, they understand Urdu as well. So we have a combination of English and Urdu. However, for the lecture specifically, I am, making most of the lectures in English. Okay, most of the part which I speak will be in English, inshallah. So you don't need to worry about that. As you can see that my previous lectures, in last 1 year, which I've uploaded on my YouTube channel, those are in English as well. All right, so you know LCM would be x plus 2 multiplied by 2x minus 1. So you need to ask yourself by what term you multiply x plus 2 such that you get this complete expression x plus 2 into 2x minus 1. Come on, hurry up. You will multiply it with 2x minus 1. Okay, you will multiply it with 2x minus 1. So the numerator 2x plus 3 will also be multiplied by 2x minus 1. So 2x plus 3 multiplied by 2x minus 1, and then we have the subtraction sign. And x plus 2 into 2x minus 1 is multiplied by 1. Okay, such that you get this expression. So this numerator is also be going to multiply it with 1. This numerator will also be multiplied by 1. So this will come as it is after this subtraction sign. Okay, so I'm going to expand and simplify. So 4x square minus 2x plus 6x minus 3 minus 9 minus 2x divided by x plus 2 into 2x minus 1. So 4x square plus 2x minus 12 divided by x plus 2 multiplied by 2x minus 1. Okay, so after this, this step, you can do this step, and immediately after this one, you can do this step. Okay, this one, then this one, and then this one. But my usual practice is to do factorization always wherever I feel it's quick and effective for me. So I just do it. Okay, otherwise you can use your calculator equation function mode. That's fine. I'm just highlighting the steps. This one, then you come on to this one because you need to take this integer 2 as common. Okay, and then you come on to this step and then you carry on. So, you know, these steps you can completely ignore. That's basically the thing. I hope this is very, very obvious to you all. All right. And if you want to, ask anything else about this or any other query, you can just always contact me on WhatsApp. I'll be more than happy to help. Anyways, this 4x squared plus 2x minus 12 divided by x plus 2 times 2x minus 1. So I took 2 as common in the numerator, so 2x squared plus x minus 6. And then this is divided by x plus 2 multiplied by 2x minus 1. So here I showed the factorization steps. So 2x squared plus 4x minus 3x minus 6, taking 2x as common multiplied by x plus 2, taking minus 3 as common multiplied by x plus 2. And therefore the complete factorized form is 2 multiplied by x plus 2 multiplied by 2x minus 3 divided by x plus 2 multiplied by 2x minus 1. So congratulations, x plus 2 and x plus 2 got cancelled out, eliminated, intakal. So 2 multiplied by 2x minus 3 divided by 2x minus 1. So what we need to do, we need to show fx in a particular form, in a required form. So we are just going to multiply the numerator. Okay, we are going to expand the numerator. So 4x minus 6 divided by 2x minus 1. This is supposed to be your answer. All right, so this was question number 3 of the handout. One last question for this recording is left. Okay, I hope you have copied this much. Okay, so now let's move on. All right, so coming on to the last question of this recording. Okay, and then we are going to conclude this lecture. Okay, so this is question number 4, January 2008, C3, question number 1. Given that 2x raised to the power of 4 minus 3x square plus x plus 1 divided by x square minus 1, we need to express this into its identity ax square plus bx plus c plus dx plus e divided by x square minus 1. Find the values of constants a, b, c, d, and e. Okay, so here you have two approaches. Either you can do it in this way, in which I have done by using the long division method. Okay, or alternatively, you can use equating the coefficients method as well. Alternatively, you can use equating the coefficients as well. All right. So in my online class, I discussed this question using this approach. Okay, by dividing the polynomial, okay, with the divisor, by the divisor, and in more questions, I'll be using equating the coefficients as well. However, equating the coefficients technique we have used in the textbook exam style questions and examples. Okay, so if anyone is interested in joining the complete batch, complete course, okay, the previous recordings will be provided to you, inshallah. Okay, so just another shameless promotion of my online classes. Alhamdulillah, I'm very shameless. Okay, I have no shame in promoting my work. So you feel more connected with me when you are enrolled in my online classes. Okay, so you'll get a chance of getting more connected with me when you are enrolled in my online classes. All right, so you are going to get the complete recorded lectures access as well. So anyways, I was just saying that I have discussed many other questions by equating the coefficients method. Anyways, let's just come on to this point and conclude this lecture. So we need to divide this polynomial, polynomial of degree 4 by a polynomial of degree 2, meaning we need to divide this quartic polynomial by a quadratic polynomial. Okay, polynomial is divided by divisor. Okay, the question is given to us in this form, polynomial divided by divisor, and we need to obtain the identity in this form, quotient plus remainder divided by divisor. Okay, this identity is discussed, countless times in the classes as well. So you need to ask yourself by what term you multiply x square such that you get 2 multiplied by x raised to the power of 4. Okay, you multiply it with 2x square. Okay, so you get 2x raised to the power 4 underneath 2x raised to the power of 4, and then this 2x square is multiplied by 0x, so you will get 0x cubed. And whenever you are using this method, you will always write the polynomial in a strict sequence. Okay, 2x raised to the power of 4, then we have the term in x square, so we are going to write it like this, that the coefficient of x cube is 0. Okay, this is the recommended way to do this. All right, always write the polynomial in a strict sequence when you are using this method. This thing we are discussing since P2 as well. Okay, so I hope you have covered this thing. Anyways, this 2x square will be multiplied by 0x, so this will be 0x cube, and then this 2x square will be multiplied by -1, so this will give you minus 2x square, and then this expression is multiplied by a minus sign, so the sign of each and every term gets changed. Okay, and this term gets eliminated, and this 0x cube minus 0x cube is itself 0x cube, and minus 3x square plus 2x square will give you minus x square, and x is going to be carried forward and 1 is going to be carried forward. Why I carried forward these two terms? Because here, in order to do the comparison, you have exactly 3 terms, and here you have also exactly 3 terms, and since in the divisor you have x square minus 1, right? So again, a strict sequence, x square plus 0, x minus 1. Okay, I've discussed these all of the things in the P3 lectures as well, and even in the P2 lectures as well, P2 classes as well. So that's basically the thing. And when you are starting the comparison next, and the first term is not existing, meaning the coefficient of x cube is 0 over here, so you can just simply ignore this term as if it is not existing. So you just start your comparison directly with minus x square. Okay, so you need to ask yourself by what term you multiply x square such that you get minus x square. Obviously you get minus 1. Okay, so minus x square will come underneath minus x square, and then this minus 1 will be multiplied by 0x, so conceptually minus 0x, and this minus 1 will be multiplied by minus 1, so positive 1. बज़ाहिरन तो elimination नहीं हो रही और वो हो भी नहीं रही होती. As you can see that the elimination is not happening over here. We need to multiply it with minus sign such that we eliminate this x squared term, meaning the term in x square. All right. So that is basically the whole idea. So multiplying this expression with a minus sign, so the sign of each and every term gets changed. Okay, and x plus 0x will give you x, 1 minus 1 will give you 0. This means that x is basically the remainder. Okay, and since the identity is that when polynomial is divided by a divisor, so this is identical to quotient plus remainder over divisor. Since we are studying a basic polynomial relationship from P2, that polynomial is identical to quotient multiplied by divisor plus remainder. So if you do an adjustment with this identity, that you divide the divisor on both sides, or you say multiply 1 over divisor on both sides. So by multiplying 1 over divisor, so this will become px over dx. This will be identical to qx multiplied by dx divided by dx plus rx divided by dx. So divisor got cancelled out and you obtained your identity. that when polynomial is divided by a divisor, so quotient plus remainder over divisor. Okay, we need to convert this improper fraction into a mixed fraction form. Okay, where this dx plus e upon x square minus 1 is basically a proper fraction. Why? Because remainder's degree is always below the divisor's degree. So this fraction is supposed to be proper fraction. Each and everything is discussed in significant amount of detail, in my online classes with my enrolled students. So I'm just repeating these things just for the sake of formality, just for making the public videos for my YouTube channel. Otherwise, if this lecture was just, for my students, then there was no need to mention these things again and again. So just for the sake of formality. So, the quotient is 2x square minus 1. So 2x square minus 1 plus x upon x square minus 1. So you just need to make a comparison. As you can see that a is equal to 2, b is equal to 0 because the term in x is not existing in the quotient. Then we have c, which is minus 1, and then dx plus e, meaning the coefficient of x is 1. So d is equal to 1. And after this term in x, we don't have the constant term. So e is equal to 0. All right, e is equal to 0. And here you go. You have successfully found the values of a, b, c, d, and e. All right, so in this way, we have attempted this question. Alternatively, you can use equating the coefficients method as well. So here I'm going to conclude this lecture. The very next lecture would be of S1. Okay, so anyways, for the sake of this video, I discussed 4 past paper questions. Inshallah, I'll be including the time stamps as well. Okay. All right. So inshallah, I'll be uploading more content for the YouTube audience, the public videos. So stay tuned to my channel. Thanks for watching. And if you have any queries, feel free to message me on WhatsApp. I'll be more than happy to help. See you in my next video. Assalamu alaikum.